Hi, I'm James Montemagno, Developer Evangelist at Xamarin, and today I'm going to show you how to leverage your C# and .NET skills to build native iOS, Android, and Windows applications with Xamarin and Visual Studio 2015. First, we'll take a look at the entire Xamarin platform and everything Xamarin has to offer. And we'll see just how to build out those native iOS and Android apps all in C# inside of Visual Studio 2015. And also we'll take a look at some popular code sharing strategies to leverage 50, 60, 70% more of code across all platforms. And of course, I'll show you just where to get started. Now the Xamarin platform is what you'll be using to build and craft beautiful native iOS, Android, and Windows applications and sharing code across all those great platforms inside of Visual Studio. Now, our approach to mobile development is extremely unique. We enable you to build a shared C# backend for your mobile applications, all your business logic, models, view models, RESTful service calls, SQL databases, things that are common across all the platforms. And then we give you the tools inside of Visual Studio to craft great native experiences and user interfaces for iOS, Android, and Windows, and access all of the native APIs. Now, if you're a Windows developer today, the .NET libraries are going to look very familiar to you. System data, link, XML, things that we know and love as .NET developers. And when you go to a new Windows platform, phone, store, desktop, you get some platform-specific APIs to mess around with, like phone or storage. And you can think of it the same when you use Xamarin to build out iOS and Android apps. You still get all of the .NET goodness, such as data and link and XML, but we give you 100% API access on both iOS and Android for all of the APIs. And then you get to take advantage of C# features like link, async await, lambdas, delegates, events, things that we know as C# .NET developers. And of course, we do the same thing over on Android, but with the Android APIs. Now we have great tooling inside of Visual Studio to get you up and running with our iOS designer for Visual Studio to craft great iOS user interfaces, and of course our Android designer built right into Visual Studio 2015. Now, when you install 2015 for the very first time, it's super simple to get started with Xamarin. Simply select the custom install option, and that will bring you to this next screen, and under cross-platform mobile development, you'll see Xamarin. Simply install Xamarin as part of your installation and we'll take care of the rest. Now, if you already had Visual Studio 2015 installed, simply head over to xamarin.com/download for our universal installer and we'll take care of everything for you to get you up and running building those cross-platform mobile apps. Let's take a look at just how easy it is to get up and running inside of Visual Studio 2015 with Xamarin to build native iOS, Android, and Windows apps all in C#. Here I am inside of Visual Studio 2015. Now I've already created my project, but if you want to get started, simply select File, New Project, and this will bring up the project dialog. When you have Xamarin installed, you'll see Android and iOS project templates for a blank Android app, Android Wear application, even a WebView or OpenGL app. And under iOS, you'll find Apple Watch, other extensions, and of course iPad and iPhone applications to get you up and running building a single iOS or Android app. But to start to build a cross-platform mobile app, under Mobile Apps, you'll find blank applications with either a portable class library or shared project. Now I've selected a blank app, native portable, and named it New App. Now we'll see in our project dialog, we have a blank new application with our shared code in our portable class library, an Android application, an iOS application, and a Windows Phone application, all referencing the same shared code. Now at this point in iOS, I can go in to my Add References, go to any of my assemblies, and bring in popular libraries that I know and love, like System.json, System.http, or System Service Model. Now I've selected and double-tapped on main.storyboard. Our storyboard is an overview of our entire application. And this is where you'll be creating your native iOS user interfaces inside of Visual Studio with our iOS designer for Visual Studio. Here you have a full toolbox available for you with every single native control in iOS. So if you wanted to bring in a switch, just go ahead and bring it over, drag and drop it on. Here I have a button, and every time I click this button, I want to just simply increase the count. I can come down to my property window, come down, maybe rename this and say click me, and we'll see the designer update in real time. If I want to add a click event, simply double click. And now we've added a click handler right in our code behind of our UI view controller. I have a little bit of code here, a little public integer with a get set. We'll set it using some C#6 properties, and then I'll create a method called increaseCount. Now instead of using a string format, we'll use a brand new C#6 syntax, and we'll say you clicked this many of times. There we go. And of course, we'll want to increase our count ahead of time. Now in our click handler, we can say button click set title, and we'll simply pass in the string. Say increase count, for the normal state. So now whenever we click that button, we'll increase the count, get a new string using C# and C#6 features. Now in our toolbar, we'll see some brand new drop-downs. We can see here I have my iPhone 5S selected, and if I had a physical iPhone plugged into my Mac, I'd actually see it in that list. We have other toolbar options here for iOS to ensure that you're up and running connected to your build host. I've selected the iPhone 5S in my dropdown. I can simply start debugging. This will build and compile my native iOS application and bring it up right on my iOS simulator. Here we go, our iPhone simulator is up and running. I have my click button, and now every single time I click, we increase the count, and we have a new string that's set to our button text. And now, of course, I have my switch that I put here in the designer. But what about Android? Let's take a look at our new app.android. Here we have resources, and if I zoom in, we can see it has all of the native Android resources, such as drawables, layouts, and values. And layouts here are all of our XML overviews of our single pages. Main.Android XML gives us a little button that says Hello World, click me, but I still have access to all the toolbox and UI Android widgets, and of course all the properties down here as well. I can see what this looks like in landscape mode or in portrait mode, different versions of Android. I can see the actual source in the code behind. Now, every single Android XML has some code behind it as there. So here's the main activity.cs. We have the same exact code that we saw over on iOS. We have our public count, get set, increase count, and here we simply find the view by ID and increase that count and set that to the button text. I'll set the Android application as my startup, and here we'll see any of the Android emulators you have installed when you installed Visual Studio, and I also have a physical Android device plugged in. I'll simply start debugging, and this will launch a debug session right on my device. Here we go, I have the button, I can simply click on it. Now I set a breakpoint in my C# code behind, and there we go. Sure enough, a full breakpoint, I can get all the IntelliSense that I want, including looking at the native Android widgets. I'll go ahead and remove that breakpoint and continue on. And we can see now, as I increase my count, building out native iOS and Android applications, all in C# inside of Visual Studio 2015. We just saw how to get started inside of Visual Studio 2015 to build out native iOS and Android applications all in C#. But what about code sharing? Let's take a look real quick at some popular code sharing strategies that will enable you as a C# developer to share 50, 60, 70% more code across all of your platforms. Now, I love portable class libraries. They enable you to build a single assembly to target multiple platforms. Simply select what you want to target, such as iOS, Android, Windows Phone, or Windows Store, and write all of your code in one project and share it across all your platforms. You can combine that with the power of NuGet to bring in popular libraries such as JSON.NET, an HTTP client, or Azure Mobile Services to bring these into your own portable class libraries and projects to add great functionality. In addition to portable class libraries and NuGet, we also have the ability to use shared code projects. Introduced in Visual Studio 2013 and available in 2015, it's a drop-dead simple way of sharing code across all of your different platforms. Let's take a look at these popular code sharing strategies to build out great native iOS, Android, and Windows applications inside of Visual Studio 2015. Here we are back in Visual Studio 2015. We just saw how to build out those native iOS and Android applications, but what about sharing code? When we created our application, it automatically created a shared portable class library for us, and it gave us a class. Let's see if we can share some code across our different platforms. Now we have this method here called increaseCount that's in our view controller, so let's go ahead and move that method. and go into our class that's in our shared code and paste it in there. It's the same code that we're using on iOS. Now, in our view controller, we can simply declare our class, which right now is just doing some business logic and increasing the count, but it could be RESTful service calls or SQLite databases, or all of our models or view models. Then I can simply call shared and increase count. Now I can head over to my main activity, and my Android application have the same shared code with my button click handler and call that shared code. Now, what we can see here is that all we're doing is referencing our shared portable class library, and the same thing is true for our Windows Phone application. If I drop down my references, I have my new application. I could go to the code behind on my main page, and sure enough, if I come up and type in shared class and say my class, I have access to all of the same properties and methods in my shared code. Now I'm sharing code across iOS, Android, and Windows, all from a single portable class library. But what about a more complex application? Let's take a look at the Xamarin Store application. I'll pull it up for both Android and iOS. The Xamarin Store application is a pre-built application template that you can download and get up and running, and even order a free C# shirt. You can browse shirts for both iOS and Android, select your size, and even place an order. It has great animations. But what about this application? How is it structured? Well, let me flip over to my other instance of Visual Studio. And the Xamarin Store application has an iOS, Android, and a shared project. And our shared project has all of our business logic, our models, view models, and RESTful service calls with our client. Here, for instance, is our product with different product sizes, names, descriptions, and our web service. Our web service is going out, authenticating our user, logging them in, all asynchronously, and getting our product list and deserializing everything with JSON.NET. I could come into my Android application, pull in more NuGet packages, or go to our component store and add more components, which is a hand-created list of great libraries for your business logic and your user interface. Here I could browse and add SAP or Signature Pad or Azure Mobile Services. I've already added it here to my application, so now right in my shared code, I could come into my usings and say using Microsoft.Windows-Azure.Mobile Services. Now I can access everything I know and add a great backend to this application. And that's just how simple it is to get up and running, building out great native applications, and sharing code across all the different platforms. Now, we just took a look at some popular code sharing strategies inside of Visual Studio 2015 with Xamarin to share code across iOS, Android, and Windows. And with Xamarin, you're always up to date with the latest and greatest technology. We've been shipping same-day support for iOS since iOS 5, and it's not just about phones and tablets anymore. We also have full support for Apple Watch, Android Wear, Google Glass, and all of the great Amazon devices such as Fire TV, enabling you to take your C# and .NET code to brand new emerging devices. Now, we took a look at the Xamarin platform today, which is just part of Xamarin as your complete mobile solution. Because we think about not just about building and designing iOS and Android applications, but what about the testability? Of course, you'll test your business logic with NUnit or XUnit unit tests, but what about the user interface? How do you ensure a great user experience across the tens of thousands unique devices in the market? Well, that's where Xamarin UI Test and Xamarin Test Cloud come in. Build C# automated user interface scripts with Xamarin UI tests and ship those to the Xamarin Test Cloud, where you can test your iOS and Android applications across thousands of physical devices. But what about after you ship your apps to the App Store? How do you ensure that you're getting feedback from your users with crash reports and analytics? Well, that's where Xamarin Insights comes in, enabling you to monitor your applications for iOS, Android, and all Windows platforms from just a single line of code. And we have great places and resources to get you started, not only with great documentation, but with live interactive instructions with Xamarin University, where you hop online and interact with real Xamarin University instructors to become a fully certified Xamarin developer. And Xamarin University offers a full free 30-day trial to get you up and running to build out great cross-platform native applications with Xamarin and Visual Studio 2015. Head to xamarin.com/university to learn more. And of course, if you just want to learn more about Xamarin, head over to xamarin.com. And to download the store application and other great pre-built applications to get you up and running, head to xamarin.com/prebuilt. And thank you so much.
To introduce myself, I'm Ankit Asthana, a program manager in the Visual C++ team. One of my focus areas is to work on cross-platform mobile development experience for Visual Studio. Today, specifically, I'm going to start with providing you a very short overview of cross-platform mobile development. I will also follow this up by highlighting the key capabilities that Visual C++ is going to provide to aid the cross-platform development story. I will also demonstrate these capabilities through the help of a short demo. Modern development today requires developers to provide their applications across multiple device platforms. From an application development perspective, C++ serves as a great choice as it allows developers to reuse their cross-platform code across a variety of device platforms, keeping the development costs low. Starting with Visual Studio 2015, Visual C++ will provide a great experience for cross-platform development. Using Visual C++ 2015, developers will be able to acquire all their cross-platform mobile development software easily and stay current with frequent updates. Visual C++ 2015 will also allow developers to build cross-platform mobile applications leveraging C++ for all major mobile platforms. In addition to this, Visual Studio Experience will also allow developers to share and reuse their cross-platform code easily, and top this by providing the fastest debugging experience for all these mobile platforms. With that said, let's now demonstrate these capabilities through a short demo. As a part of the File New Project menu, developers will now see the cross-platform node light up under Visual C++. With this node selected, developers can view a wide range of templates made available to them. Let's take a look at a few of them. The Dynamic Shared Library template will allow developers to create a dynamic shared library for the Android platform. This library will contain all the C++ code and can then be used to create an end-to-end application using Java or Xamarin. The other newly added Basic Application Android template allows developers to create an end-to-end application in Java. And the Makefile project template will allow developers to port over their source code easily from other IDEs as it leverages NDK build. Also notice the cross-platform templates, which are used to target and share cross-platform code between multiple platforms, including iOS, which we enabled recently. The last template that I want to talk about is the Native Activity template. Android with API Level 9 released the ability to create a complete end-to-end application in C++. This style of application is popular with game engines and other game-like things. Let's further explore this template type by looking at an example. So here I have the OpenGL example solution. It has two projects. The Native Activity project contains all the C++ code. Let us further explore the project by taking a look at the project properties. Project properties allow users to view, edit, modify important project characteristics. For example, using the target API level project property, developers can set the API level that they want to target for their application. Using the Platform Toolset property, developers can choose the platform toolset that they want to choose for building their application. We currently support both Clang and GCC toolchains. The last property that I want to talk about here is the Configuration Type project property. This property allows developers to choose what kind of application they're building. In this case, we're building a dynamic shared library or an SO file. Let's now hit cancel and take a look at the other project. The packaging project is used to take the existing dynamic shared library and create an end-to-end Android application using the Ant build system. For the next part of the demo, I want to bring up some source code to demonstrate the feature capabilities. For doing so, I'm going to bring up the main.cpp source file and traverse to the Android_main function. Android_main function is a characteristic function for native activity application type and acts as an entry point. As I play around in this function, notice some of the code authoring features that we've introduced. For example, the Android specific IntelliSense experience lighting up here as I choose the Android LockPrint API. Other features for code editing and authoring, such as code navigation, work well as well. To demonstrate this, take a look at the peak definition feature in action here. All in all, we've ported most of our code authoring features from the Windows experience and extended them for the Android platform as well. This will provide you a good code editing experience when developing inside Visual Studio. For the next part of the demo, I want to go ahead and show you the debugger capabilities. For doing so, I want to set a bunch of breakpoints. Notice the drop-down debugger menu is already populated with the fast x86 Microsoft Android emulator. This emulator is already running in the background. So I'm just going to go ahead and hit F5. On hitting F5, my application is built and then deployed onto the emulator. Notice the breakpoint that I set was hit. Also notice the debugger windows such as the auto window, the locals window, the threads window, and other debugger windows such as the call stack all light up nicely as well. As I mentioned, the Android debugger inside of Visual Studio that we've developed is the fastest debugger on the Windows platform when debugging Android code. To demonstrate this, notice as I actually move between different breakpoints. Furthermore, using this debugger experience, developers can also pass commands directly to GDB using the command window. For example, in this case, I'm viewing the backtrace for my application that's currently running using GDB exec. Next, I'm going to hit continue and let the app run. This app is a basic OpenGL app and it responds to user touch by changing screen color. Notice that happening as I click on the emulator screen. The emulator itself also has other capabilities. For example, you can rotate the screen and view how your application actually operates. I'm going to hit continue again because my debugger breakpoints were hit. Or you can also leverage other sensors that the debugger actually provides. We currently support the accelerometer sensor, the location sensor, the network sensor, and so on. All in all, this is our development experience for Android when using Visual C++. In the next part of this demo, I'm going to show you how to debug a pre-existing Android application package file that you built in another IDE. For doing so, bring up the File New Project menu and choose the Dynamic Shared Library application type. I'm going to name this project Debug Pre-Existing Big Maps APK and click OK. On doing so, this creates the Debug Pre-Existing Big Maps APK project type. Choose the configuration that you want to debug for and hit Build. Next, bring up the debugger property pages and fill in the following information. This information includes the package to launch, which is the path to the APK, the package name itself, which can be found in the Android manifest.xml, the launch activity, which can also be found in the Android manifest, And last, the symbol search path, which contains the symbols for your application type. Click OK. The next thing we need to do is bring some source from the Big Maps application so that we can debug it into Visual Studio. For doing so, I'm going to bring up the map network manager.cpp source file into VS. Since we will be using this project only for deploying this application and not building, I'm going to uncheck Build in Configuration Manager and click Deploy. I'm going to set a breakpoint in this begin get URL function, which gets called during the Big Maps initialization. At this point, I'm ready to debug my Big Maps APK using Visual Studio. All I need to do now is hit F5. Notice that this application is getting deployed to your device. The Big Maps APK is pretty large in size, and the symbol search path contains over 500 MB of debug information, which is currently getting loaded, as you can see from the loading symbols. Notice that the breakpoint that I set was hit, and the autos and the locals window all light up nicely as well. Using this experience, developers can use the Visual Studio Debugger for their pre-existing Android application package files without moving completely into Visual Studio. Thanks for watching this video. To learn more about cross-platform mobile development, follow us on visualstudio.com or VC Blog.
Hi, my name is Amanda Silver, and I'm Director of Program Management for the team that creates Visual Studio's tools for client applications. Today, I want to share some new features with you that will allow you to use the power and productivity you've come to love in Visual Studio to build mobile applications across iOS, Android, and Windows devices. What I'm talking about today is the development tools to build client applications. But modern mobile apps are much more than just creating a responsive, touch-enabled client. The best applications are connected, kept up to date, and deliver engaging experiences to their end users. Microsoft offers a complete stack solution to build your mobile applications to help you build rich experiences that includes push notifications, secure authentication, real-time updates, and connectivity to common software as a service platforms, along with comprehensive DevOps tools to facilitate a rapid release cadence. Let's dig into the different approaches for building a mobile app. There are two common approaches to building mobile applications: native and web. Developers using the native platform technologies create native apps for each device by using the tools provided by each mobile vendor: Xcode in iOS, Android Developer Tools for Android, and Windows Universal Apps based on WinRT. But these developers often struggle with the ability to reuse code and skills across devices, especially considering that the average developer ends up targeting more than 2 mobile platforms. Developers also use web technologies to create browser-based applications optimized for mobile browsers. As the browser is constrained, developers struggle with the ability to create applications that can leverage the full capabilities of the devices they target. They also often want to make their apps available in the public app store. The path of a mobile app developer often begins with a choice: develop for iOS, Android, or Windows. It's a choice that instantly diminishes the size of your potential audience, but developers often hold their nose and reluctantly make a decision. Those who need to reach all 3 app stores have to rewrite the application for each platform. Visual Studio enables you to have maximum reach while achieving significant code reuse. With Xamarin, C# developers can share business logic across iOS, Android, and Windows applications. With Apache Cordova, web developers can achieve maximal code reuse by building cross-platform mobile applications using HTML, CSS, and JavaScript. Xamarin in Visual Studio allows you to create rich native apps across multiple platforms: Windows, iOS, and Android, while maximizing code reuse. With Xamarin, you can build fully native apps with immediate access to device capabilities. You can build highly customized experiences per device with fully native user interfaces, so you can deliver the best UX and performance in the devices. 100% of the native APIs are exposed, so everything you can do with Xcode or ADT, you can do with .NET and Visual Studio. Now let's take a look at the Xamarin demo. With the Xamarin extension for Visual Studio, C# now has templates to target Android and iOS. As you can see here in this solution, I've already created an app that targets both Android and iOS, as well as Windows. As you can see up here, a bunch of the application is actually defined inside of a portable class library, which allows me to get dramatic amount of code sharing across the different applications. In fact, even my view models are shared across the different applications. So I really only have the very thinnest presentation tier defined for iOS and Android. To create a portable class library, we can just go in and go to the properties. And as you can see with the Xamarin extension, I can target Android and iOS for those portable class libraries. And that's how we get the high degree of sharing. Now we can go into the Android application. And if we go into an example file here, let's say we go into the views, we go into the vehicle detail view, you can actually see that, I now get IntelliSense for Android. Additionally, as you can see, for the iOS application, I can even go in and get a common storyboard design experience. So as you see here, this is like a normal Visual Studio drag and drop kind of WYSIWYG designer that's part of the Xamarin extension for Visual Studio. If we zoom out, you can actually see that this is much more than just a one-screen design experience. We actually have the entire storyboard defined out here for the entire application. So let's just go ahead and deploy the application to the device that I have tethered to the machine that's running Visual Studio. Now we can see that it's building, and it's actually in the process of being deployed now. Now you can see the two screens kind of side by side. You can see the debug output actually coming through to Visual Studio. And you can actually see that it's like an Android experience. The navigation is along the top. I can go ahead and hit the Chevy Volt, and you can see that I actually hit a breakpoint in Visual Studio. And then I can just go ahead and continue it, and you can see that the application paints, and we can see what's running on the Android device here. I can go ahead and request that, and you can see that the vehicle has been requested. So we get the entire debugging experience in Visual Studio for an Android device. With Xamarin, you can create UI with drag and drop simplicity, target multiple screen sizes, resolutions, and OS platform versions. You have the world's best Android designer available in Visual Studio, and the layouts are saved in native resource formats. When you build with Xamarin, you don't have to compromise on performance. On iOS, Xamarin performs full ahead-of-time compilation to produce an ARM binary. On Android, it takes advantage of the just-in-time compilation on the Android device. Visual Studio tools for Apache Cordova allow you to create a single hybrid app for iOS, Android, and Windows with your skill set and web standards, HTML, JavaScript, CSS. Apache Cordova is an open source project that provides a set of device APIs that allow a mobile app developer to access native device functionality, such as the camera, native telephony, or even a barcode scanner from JavaScript-based APIs. It also mostly abstracts away the platform-specific packaging for each of the native mobile operating systems. Through our partnership with the Apache Cordova community, we've contributed several updates to the framework in the last few months, including support for Windows Universal projects, support for platform-specific configuration settings, and security updates which benefit all target platforms. We're working with the industry-wide community of contributors to ensure Apache Cordova is enterprise-ready. Now let's jump to the Tools for Apache Cordova demo. With Visual Studio 2015, we have templates for Apache Cordova applications under both JavaScript and TypeScript. In this case, I've created an Apache Cordova application using TypeScript. So as you can see, the application file is defined using TypeScript. But in addition to that, I'm using common JavaScript frameworks like Angular, Bootstrap, jQuery, etc. And if I expand the Angular folder, you can actually see that the Angular file is defined with JavaScript. So I'm actually using a mix of JavaScript and TypeScript in this application. The other thing that's specific to Apache Cordova projects is the config.xml. And as you can see here, I have a common app manifest, which defines the common properties for the application, but then I also have plugins. Now, plugins are the way that you access native device capabilities like the battery, camera, device orientation, etc. Now, the next thing I'm going to do is to actually deploy the application to the VS Emulator for Android. Once the application has been deployed to the device, Visual Studio actually attaches in a debug mode. And this will happen for both a tethered device and an emulator, but in this case we're using the emulator. I can now use the select element to just select something that's on my application. And you can see that the DOM Explorer actually gets updated to reflect my selection. I can go back here and just click Edit as HTML, and instead of saying Start Service, I can just make that say Start and take my cursor off, and you can see that it actually updates live. Then I can just click Start, and you can actually see that we hit a breakpoint. And as you can see down here, we have full call stack information, including anonymous function. We have complete locals and autos window, basically the entire debugging experience that you've come to expect in Visual Studio you have for Apache Cordova mobile applications. Visual Studio 2015 has new templates to create Apache Cordova apps. The tools are built on top of the existing great HTML, CSS, and JavaScript support in Visual Studio, but integrates with Apache Cordova. So you have things like IntelliSense support for Cordova plugins, can build for any targeted platform, and run and debug the app on a device emulator or a remote device. The cool thing about these tools is that you will naturally know how to use it if you're familiar with web development. It also supports the most popular JavaScript frameworks that you're probably already using for your mobile web applications, such as Angular, jQuery Mobile, or Backbone. You can also create these apps with TypeScript, an extension to JavaScript which supports the productivity and scale of statically typed languages, which is very handy for apps that can get very complex. New in this preview, you can create shared C++ components that will work across iOS, Android, and Windows and complement with the presentation tier written in Xamarin or Cordova. You can also run existing native C++ apps and attach the Visual Studio debugger. Now let's take a look at the C++ demo. With the cross-platform C++ support in Visual Studio, you can see that you can actually create an Android application, either an Android application that's entirely C++, or you can define a static or shared library that you could then use in an application that has a front end defined in Xamarin, Cordova, or even Java. In this case, we've defined an application that's using OpenGL, and as you can see, I've set a breakpoint here. I could either deploy it to the emulator, or in this case, you can see that I'm going to deploy it to a tethered device. So now we can see that the application is running here. I can go ahead and actually just zoom out. And then I can even just set a breakpoint. And you can see that I actually hit that breakpoint. And then if I remove the breakpoint and just go ahead and continue here, you can actually see that we go ahead and run that again. And if I set the breakpoint again, you can see that we hit it, and we have the full call stack, breakpoints, exception setting, and all of the locals and watch windows that you expect in Visual Studio, but against an Android device running OpenGL. As a developer, you need to build applications that support multiple platforms, can integrate with on-premises information systems and cloud-based services, as well as automatically scale globally as your business and audience grow. With Azure App Service, you can rapidly build, deploy, and manage web and mobile apps for employees or customers using a single backend. App Service is an integrated solution that streamlines development while enabling easy integration with on-premises and SaaS systems, while providing the ability to quickly automate business processes. Azure App Service brings together the capabilities from Azure Websites, Azure Mobile Services, and Azure BizTalk services into a unique integrated offering while adding powerful new features. You can use your existing language skills in .NET, Java, Node.js, PHP, or Python. If you've ever done cross-platform development, you know that compilation for each platform requires a litany of open source and platform-specific components. Building for Android requires Ant, Java, and the Android SDK. Deploying to iOS devices requires specific software. Windows requires the Windows SDK. After all is said and done, there are over a dozen toolchain dependencies that can take hours, even days, to properly download, install, and configure. Visual Studio will get you up and running quickly with a well-configured dev environment and help you stay that way. Visual Studio 2015 also includes a brand new Android emulator that is trustworthy and fast. This is where you can get the downloads and extensions that will help you start building mobile apps across iOS, Android, and Windows with Visual Studio. You can also use these resources to learn more about TypeScript, Azure App Service, and follow along as we deliver updates. Thanks.
What's cross-platform mobile development? It's reaching anyone you want, anywhere, on virtually any device. Visual Studio helps you build amazing apps for iOS, Android, or Windows. Visual Studio gets your dev machine set up fast with all the dependencies you'll need to build compelling mobile apps. You get all the basics you expect from Visual Studio, like templates, so you can hit the ground running with the world's most productive coding experiences. And visual designers, so you can jump right into development. You can even debug your apps via a tethered device or with our fast new emulator. With tools for Apache Cordova, you can leverage web technologies and the frameworks and tools you already know. Using JavaScript, HTML, and CSS, you can build a single app that runs across the major mobile operating systems without having to compromise on access to native device capabilities. If you prefer coding in .NET, we've got you covered. With the Visual Studio Xamarin extension, you can build native apps for iOS and Android with the productivity you love of C#. You can easily reuse the majority of your code across mobile solutions. Say you've got a large C++ code base that you want to take mobile. Well, you're not alone. That's actually how mobile apps for Microsoft Office are built. However you're building your app, you can easily scale to the demand with the cloud. And get insights into how your app is performing for any users, anywhere, on any device.